Okay, so today we will talk about lesson 5, which is the last lesson of your acids and bases solutions, acids and bases unit, and it is talking about Arrhenius and modify Arrhenius theorem. Now, when we see the list of acids that is on page 8 and 9 of your data booklet, you will notice that some of them, even if you notice at the last column of that table, you will see that the value of Ka is very large for some acids that are above the hydronium ion, and then you have a given value for the other acids that are below the hydronium ion. So those acids that are above the hydronium ion, which is kind of grayish in your row on the data booklet, are considered to be strong acids. And strong acids will 100% be ionized when we have them in water. And weak acids will be roughly 50% ionized. So now those acids, those 6 acids that are above the hydronium ion, are considered to be the strong acids, and that means that they will ionize 100%. So when we see, let's say, hydrochloric acid, or when we see hydroiodic acid, they are considered strong acids. But on the other hand, when we see, let's say, nitrous acid, HNO2, or sulfurous acid, so H2SO3, those are considered strong acids. Sorry, weak acid. Strong bases are any compound that contain hydroxide. When we see the hydroxide, OH, the OH minus, but the hydroxide, then we will have a strong acid. But so examples maybe sodium hydroxide, or potassium hydroxide, or calcium hydroxide. Anything like this is considered to be a strong base. But when we look at ammonium, NH3, this is considered to be a weak base. Now, Arrhenius theory is saying acids, it's defined as an acid, any compound that when it is ionized, it produces the hydrogen plus. So any defines as a molecular compound, any acid is a molecular compound that it is ionized. When it is ionized, it produces H plus. For example, if we have hydrochloric acid, we have gone through this example so many times. So then what it is produced is hydrogen plus and a chlorine ion, chloride in aqueous solution. So in this case, what we have is the production of the hydrogen plus. Remember what I said, that Arrhenius didn't have the idea that actually in aqueous solution, what we have is hydronium, because this hydrogen plus is very active and will be attracted to the lone pairs of oxygen at the water molecule to form the hydronium. So Arrhenius initially didn't even know this fact. And Arrhenius defined as a base when a compound is dissociated and in water to produce the hydroxide. So an example of this will be, let's say, sodium hydroxide. In aqueous solution will be sodium plus OH minus, or any other base. But now the question will be, what is ammonia? Is it an acid or is it a base? So ammonia is considered to be a base but it doesn't produce, even though that is not producing hydroxide. So now the question will be, is Arrhenius theory correct, or do we have to do some modifications on it? And this is where the modified Arrhenius theory comes into place. The modified Arrhenius theory is stating that when dissolved substances, so when dissolved substances collides with water, to either steal or donate hydrogen from a water molecule we will have, depend on if it is stealing or if it is donating, will have a base or an acid. Okay, so now when the water molecule is taking the hydrogen, then what we have is hydronium. So think about this as hydrogen or water is something like this. So when this hydrogen is given away, then what is left is the hydroxide. And when the hydroxide is stolen, given away, then we are left with the hydrogen. So what it is happening here, the hydrogen acids will donate the hydrogen plus to water molecule to form that we have said now, we have established that is hydronium, H3O+. Okay, so it's a hydronium. So when we have, let's suppose that we have HBr in aqueous solution. So what is happening? We'll have a hydrogen and water, okay? So what this hydrogen and the water will form that is known as the hydronium, okay? Plus Br in aqueous solution, this of course, Br minus in aqueous solution. And this is a reverse kind of equation. So this hydrogen is donated by the acid to the water molecule to form hydronium. But bases steal the hydrogen. So see what is happening at bases. They steal the hydrogen to form the hydroxide. Okay, so let's say that we have an H3 in water. Okay. So what is happening now? One of those hydrogen is stolen by the ammonia. And then what is left is NH4 plus in aqueous solution plus OH minus in aqueous solution. So this is making ammonia a base. Okay. So let's see an example of identifying if it is a base or if it is an acid using the modified Arrhenius theory. So first one, HNO3. Okay, what is it? Is a base or is an acid? So HNO3 will be in aqueous solution, which means that the water will be present there, liquid, not, okay? The water will be present there. So then what is happening is a reaction that happens in both sides, okay? It's a double reaction. Some products are becoming reactant and reactant are becoming product. So what is happening here? The hydrogen is stolen by the water molecule to form H3O plus and NO3 is minus. So since we have the presence of hydronium, then this is an acid. Let's take a look at SO4, 2 minus in aqueous solution. Okay, in aqueous solution, that means that we will have water here. So again, what is happening here? The hydrogen is stolen by the SO4. Is stolen by SO4 to form. We have it there, hydrogen sulfide. So then will be HSO4. Now, by stealing one positive hydrogen, this becomes -2 plus 1 will be -1, just -1 in aqueous solution, and the water molecule is left with the hydroxide, which will make it a base. Let's see now another one. Let's see this O3 minus in aqueous solution. In aqueous solution means that we have the presence of water. Okay. So now what is happening here is one hydrogen is stolen by the O3 and hydrogen is positive, so it will be +1. Then this turns out to be HbO3 2 minus, because -3 + 1 is 2 minus in aqueous solution, plus OH hydroxide, and this will be a base. So let's talk now about monoprotic and polytropic acids. Monotropic acids are acids that have only one hydrogen atom. So what is happening? They will react with one water molecule to produce hydronium. So on the case of HNO2 in aqueous solution, meaning that it is in the presence of water, will take this, will donate that hydrogen, and then will produce a H3O plus and NO2 minus in aqueous solution. So when we see this, then we say that we will have one hydronium produced here. However, when we have polyprotic acids, then we have more than one hydrogen that is available to be donated. Okay. Now, this on this case, more than one hydrogen can be reacted. However, the first one is the most significant. So more than one hydrogen can be reacted, can react more than once. However, only the first one is significant. So when we have H3PO4, then this is a polyprotic acid because we have 3 atoms of hydrogen that are available for reaction. And because we have more than one, has 3, which is more than one hydrogen that is reacting. So, and when we have the amphitropic substances, then they can donate or they can steal protons. They go both ways. They donate or they steal. Depend on the situation that they are at. They can donate or they can steal. So let's see, HSO4 minus in aqueous solution, meaning in the presence of water, will be either stealing one and then becoming H2SO4 in aqueous solution plus OH minus, which will turn out to be a base, but still HSO4 minus in aqueous solution as H2O liquid will be able to donate hydrogen. So creating hydronium, H3 plus in aqueous solution plus SO4 2 minus in aqueous solution. Creating on this time based on the modified Arrhenius theory, creating an acid. So it can donate to create an acid, but it can steal to create a base. Okay, so those kind of substances will have to take into the consideration as well. So let's write an equation when we see that lithium sulfate is an acid. Okay, so lithium sulfate is LiHSO4 Let's write a dissociation equation for this. So in aqueous solution, meaning water, what we will have is that this is dissociated. So Li plus in aqueous, it is dissociated. So it is soluble in water, therefore will be dissociated, plus HSO4 minus in aqueous solution. So now for the modified Arrhenius, we are proving here that is an acid, okay? We are proving that is an acid. For a modified Arrhenius, what we will have is this HSO4 minus in aqueous solution plus water. The water is present there all the time. We will have the hydrogen will be stolen from a water molecule. So we'll have SO4 2 minus plus H3O in aqueous solution, of course, plus, since we have the presence of the hydronium, then this is an acid based on the modified Arrhenius. Let's take a look on the other one. We have, could sodium phosphate be an acid or a base? Write equations to prove that. Okay, so now let's take a look. Potassium, oh no, it's, what is it? Sodium phosphate. Sodium phosphate is Na3PO4. PO4 in aqueous solution will be dissociated. It is able to dissociate because it is soluble. So then we will have 3 sodium plus in aqueous solution plus PO4 3 minus in aqueous solution. Now this those entities are in water. That means that PO4 3 minus in aqueous solution plus water, liquid. Then we will have 1 hydrogen be stolen by PO4. So we will create HPO4. Now, -3 plus 1 will be -2 in aqueous solution plus OH minus in aqueous solution. So then this is a base. Let's do another example when we are writing dissociation of potassium carbonate. Okay, so let's take potassium carbonate. Potassium carbonate is KP, no, C, sorry, KCO3, K2CO3 in aqueous solution. It is dissociated, so let's write a dissociation equation. 2K plus in aqueous solution plus CO3 2 minus in aqueous solution. Okay, so now we take this and then we write a modified Arrhenius. Okay, write a modified Arrhenius. CO3 2 minus in aqueous solution plus water molecule or water liquid will give us HCO3 minus in aqueous solution. Why minus? Because -2 plus 1 is -1 plus OH minus. So that means that what we have here is, since we have the presence of hydroxide, then we have a base. Even though that when we see it, it looks like salt, actually it's a base. It's a weak base. Now you can complete the assignment on lesson 5. Do all those questions, and we will deal with questions like this in class.